Hello, my name is Naisha Jain, and I'm from Coppell, Texas.
Hi, my name is Claire Necaise, and I'm from Pascagoula, Mississippi. Naisha and I are on the 2023 NASA Seas Urban Heat Island team. And our research topic this year was on how the urban heat island affects agriculture land. So, some background on our topic. We chose to examine the correlation between agriculture and urban heat island because of how important agriculture is to society. It provides us with food, clothing, and is also an important economic factor for the United States. So, some terms we will be using is the urban heat island effect, which is a scientific theory that cities withhold more heat than their surrounding rural areas due to the lack of vegetation growth, which occurs because of modern buildings and other infrastructure. We will also be using the Normalized Difference Vegetation Index, which we will refer to as the NDVI, and the Land Surface Temperature as LST to better understand the urban heat island effect. So our research goals were to determine how the urban heat island effect impacts the vegetation of its surrounding rather than observing the vegetation within the city. So instead of trying to prove what was happening to the vegetation within the cities, we wanted to look outside the boundaries of the cities into the rural surrounding areas to best observe the urban heat island impact. So based on our topic goals, we formulated two research questions. The first is, what is the correlation between the urban heat island effect in Salem and Portland and vegetation cover in Willamette Valley, Oregon? And the second, over the past few decades, how has the urban heat island effect in Salem, Oregon influenced the surface temperature of Willamette Valley? To find the most accurate answers to our research questions, we wanted to find an area that had agriculture land surrounding large cities. So, for our study area, we chose Oregon for its rich farmlands and forestry, and also its largely populated cities. Within Oregon, we specifically looked at the cities of Salem and Portland, which are both surrounded by the Oregon Willamette Valley. And our time frame for our study was 1 to 2 decades during the summer season, so during the months of June, July, and August.
We primarily use Google Earth Engine, specifically datasets from Landsat 8 and 9, to collect both quantitative and qualitative data for Salem, Portland, and the Willamette Valley. Additionally, we use datasets from USGS, ArcGIS, and GLOBE to support our findings. On to our first research question, which essentially observes the correlation between the LST of two cities and NDVI of the valley. This data table holds all of the summer monthly averages for LST and NDVI for these three locations, and this data came from Google Earth Engine. This graph illustrates the NDVI versus LST for these three locations. There appears to be a slight positive correlation between these variables in Salem and Portland. However, in the Willamette Valley, there appears to be a constant relationship between the variables as its trend line is horizontal. Statistically speaking, we use the Spearman correlation, which ranges from -1 to 1, where the endpoints indicate strong correlation between the two variables and 0 means no correlation. When assessing the LST and NDVI correlations in all three locations, we found that the correlation was 0.248 in Salem, which indicates a weak positive correlation. In Portland, the correlation was 0.329, which indicates a moderate positive correlation. Finally, in the Willamette Valley, the correlation was 0.002, which indicates hardly any correlation. To visually demonstrate this correlation, we extracted a geospatial map from the Willamette Valley's summer season in 2016. In the western part of the LST map, the area appears to be 50 degrees Celsius. In the southern large plane of the same map, the area appears to be around 40 degrees Celsius. On the left-hand side NDVI map, both of these regions appear to have similar, close to zero NDVI values, regardless of the LST values. This illustrates how the LST and NDVI values are not influencing one another to a great extent. To take our research one step further, we also observed both of these variables over time. Starting off with the NDVI graph here, we can see that for the majority of the years, the NDVI was the greatest during the month of June. These NDVI values tended to exceed 0.6, which indicates dense vegetation. After June, over the past decades, the NDVI values typically declined over the next summer months. This graph illustrates the LST values of all three locations over time. Typically, the LST values were the greatest in Salem among the data we collected. This is surprising because Portland is more urbanized with skyscrapers and more infrastructure in comparison to Salem. Thus, intuitively, based on the urban heat island effect, we would assume that Portland would have the greater LST values. However, our findings appear to contradict this idea. Our final graph illustrates both variables over time. As depicted in these gray regions, in the past, the NDVI had longer spans of direct relationships with the LST values. As we progress towards modern day, this direct relationship has become weaker.
So for question number 2, we looked at how the LST of Salem was specifically influencing the LST of Wilmette Valley. This slide shows the specific correlation of the LST in Salem compared to that of the Wilmette Valley. On the left is the surface temperature for both Salem and Wilmette Valley during the summer months, ranging from the years 2000 to 2020 in 5-year intervals. On the right is a clearer visualization chart of this same data. From this, we can see that the LST of Salem has a much greater fluctuation of temperature than its surrounding Wilmette Valley. We can also see that while Salem's changes appear to be extreme, Wilmette Valley's remain steady, with a slight increase over the years. From the current theory of UHI, we would have assumed that this would not have been the case, and this data came from NOAA and the Landsat satellites. To further understand this data, we used Landsat imagery. This images on the top show the area of Salem specifically, whereas the images on the bottom show the area of the whole Wilmette Valley. You can see from these images that there is clearly a gradual increase of LST for both Salem and the Wilmette Valley, but we cannot prove that this is due to the UHI of Salem because there does not seem to be a direct correlation between the two from the data or images. And here we have data from GLOBE, with Salem on the right and Wilmette Valley on the left. This further shows a natural increase in temperature for both, but Wilmette Valley's does not appear to be as significantly influenced by Salem. Thus, this further proves that there does not appear to be a direct correlation between Salem and the Wilmette Valley, which is not what we were originally expecting based on the UHI theory.
We have concluded that there is a weak to moderate correlation between the LST and NDVI between the cities of Salem and Portland and the Wilmette Valley. Additionally, the LST values were very similar in Salem and Wilmette Valley as a whole. We have 2 more conclusions that we have listed on this slide. Here are our group's opinions on the NASA SEAS internship experience. Personally, the SEAS program boosted my passion for geospatial research and learning new softwares, regardless of the learning curves. Thus, I'm excited to continue researching and providing findings to the scientific community as a part of my future career.
Similar to Naisha, the SEAS program gave me the opportunity to learn more about the Earth data that is currently available and the different technologies and programs scientists use. I hope to attend college next year for computer science and research more ways that technology can be used to help farmers and the public. And we would like to take a moment and thank our team and all those who have supported us and our progress this summer. Here's our citation page. Thank you.